Good morning, class. We are looking at the second section, which is trigonometric functions, unit circle approach. So we looked at the first section, angles and their measures. We're looking at trigonometric functions, unit circle approach, and the next section is properties of trig functions. So what are we covering here? We want to find the exact values of trig functions using a point on a unit circle. We want to find the exact values of trig functions of quadrantal angles for angles that are common arcs, such as pi over 4 equals 45 degrees, pi over 6 is 30 degrees, pi over 3 is 60 degrees. Multiple integers of those angles. We're going to use a calculator to approximate the value of a trig function, and also we're going to use a circle of radius r to evaluate trig functions. So first, quickly, what we covered was a vertex, line, ray. This is a vertex, this is a line, and half line becomes a ray in essence. The terminal side, the positive or counterclockwise, negative or clockwise standard position, quadrantal angles, right angle, straight angle, all of the above. And so what I want to add here, also this definition, which gives the relationship between degrees and radians, because pi radians equals 180 degrees. 1 degree is 60 minutes, 1 minute is 60 seconds, and a counterclockwise, a complete revolution gives us 360 degrees or 2 pi radians. The angular velocity of omega is theta over t, which is the product of 2 pi and RPM, revolutions per minute. It could be even RPS and so on and so forth. The linear velocity v is s over t, or r omega. S is the length of an arc, r times theta, and a is 1/2 r squared theta, which is the area of a sector. So we have the initial side, we have the terminal side, and counterclockwise is positive. Clockwise, negative. Standard position when the initial side is along the x-axis. This happened to be a positive, this happened to be a negative angle. -90-degree angles or right angle, 1/4 of a revolution, 90 degrees or pi over 2, and this is half a revolution. Straight angle, 180 degrees or pi radians. So this is the synopsis of what we covered. So a circle has the equation x squared plus y squared equals r squared if it's centered at 0, 0. If the radius is 1, this becomes 1 squared or 1, and we call this now a unit circle. So this is a circle in general, this is a unit circle. Looking like that. So let t be a real number, and p has coordinates x, comma, y, be the point on the unit circle, some point of the unit circle. That corresponds to t. Therefore, this point, p, which has coordinates x, comma, y, for example, right here would be 1, 0, right here would be 0, 1, and any point has coordinates x, comma, y, where x squared plus y squared equals 1. That is a unit circle. So we have a unit circle, x squared plus y squared is 1. P is any point on that having coordinates x and y, and We define sine t, this is S or t, sine t to be y and cosine t to be x by definition. So define sine t as y and cosine t as x. So a quick recap, P has coordinates x and y. The sine function is y, the cosine function is x. So we define tangent as the ratio of y to x, where the denominator, as always, can't be negative. So if x can't be 0, the tangent function associates with t, the ratio of the y coordinate to the x coordinate of P, and is denoted by y over x. So the x coordinate represents the cosine t, the y coordinate represents the sine t, and y over x is the tangent t. Now, cotangent is the reciprocal of a tangent. Cosecant, CSE, is the reciprocal of sine, and secant is the reciprocal of cosine. Needless to say, in all cases, denominator can never ever be 0. So these are the definitions we are going to use. As long as we know these three, the answer to the rest of them would be the reciprocals. To make some sense out of this, let's look at a very simple example. So we're going to refresh everyone's memory. A point has coordinates x comma y, where x squared plus y squared equals 1. Sine represents the y, cosine represents the x. Again, as long as we have these two, we have the rest of them, because tangent is the ratio of sine to cosine. So y over x. And the rest of them are the reciprocals. So we want to find the exact values of all trig functions if P has the following coordinates: -1/2, square root of 3/2, which is a point on a unit circle. By the way, if you want to prove this is on a unit circle, you want to square this one, you want to square this one, and the sum must be 1. Okay, if somebody says prove that. So with that being the case, if we locate -1/2 and then square root of 3/2, by the way, square root of 3 is about 1.71 roughly, but you can use a calculator to locate that. So it's somewhere here, somewhere here. This represents the pair, and therefore by definition, we know the x coordinate is the sine, the y coordinate is the cosine. So the x coordinate, -1/2 is sine. My apologies, cosine. The y coordinate, that means square root of 3/2, is sine. And tangent is the ratio of sine to cosine. So y square root of 3/2 over -1/2. So sine is the y coordinate. Cosine is the x coordinate. And divide the y by x, you get the tangent. Negative square root of 3. Now, the rest of them are reciprocal. So for example, the reciprocal of sine, 2 over square root of 3, becomes cosecant t. The reciprocal of cosine, -2, becomes secant t. And the reciprocal of tangent, minus square root of 1 over minus square root of 3, which becomes minus square root of 3/3, is cotangent. So please understand this one, 1 over square root of 3 divided by 2. And again, just to, in case if anybody has any problem, it's 2 over square root of 3. If I rationalize it, I get this. As far as this one is concerned, 1 over minus square root of 3 if I multiply by square root of 3 over square root of 3, I get negative square root of 3 over 3. By the way, the negative sign can be in front of a fraction bar, can be at the bottom, or in the numerator. We normally don't put it as part of the bottom. I want to make sure that everybody is okay with that and knows that. Sorry, it didn't look good. I just wanted to make sure it does. All right. All right, we want to find the exact values of the trig functions of quadrantal angles. Theta equals 0, pi over 2, pi, 3 pi over 2. All right, we just start with the first one. Theta, when theta is 0, the coordinates for this point P is 1, 0. And we remember x, y is cosine t, sine t. So that means sine is 0, cosine is 1. Tangent is 0 divided by 1, which is 0, and the rest of them are reciprocals. So first understand these three. Now, what is the reciprocal of 0? Undefined. What is the reciprocal of 0? Undefined. Because of that, cotangent and cosecant are UD, undefined. And I hope this will help us remember these common arcs. What about 90 degrees or pi over 2? This one has coordinates 0, 1. So x is 0, that means cosine is 0. Y is 1, that means sine is 1. And then tangent is sine over cosine, 1 over 0, which makes it undefined. So again, take a look at the first three. And then the reciprocal of sine is 1, it's cosecant. The reciprocal of cosine becomes undefined. And tangent is undefined, so cotangent becomes 0. Pi or 180 degrees, location minus 1, 0. So cosine becomes negative 1, cosine of pi. Sine becomes 0. And tangent is the ratio of sine to cosine. Therefore, tangent is also 0. So take a look at the first three again. and then their reciprocals. The reciprocal of tangent is cotangent, becomes undefined. The reciprocal of sine is cosecant, becomes undefined. The reciprocal of cosine is secant, and the reciprocal of -1 is itself. 3 pi over 2 or 270 degrees. Location of P 0, comma, -1. Therefore, x, which is cosine, is 0. Y, which is sine, -1. Tangent, which is sine over cosine, becomes undefined. So look at this 3 again. And then the rest are the reciprocals, meaning cotangent becomes 0, cosecant becomes -1, and secant is undefined. Let me also fix this. This is 3 pi. This is supposed to be 3 pi. Okay, so using information from the unit circle, we can easily find trigonometric functions for all of these quadrantal angles. By the way, when we go back to 2 pi is the same as theta equals 0. So very straightforward. All right, now the definition we're going to add, we said this is T units or T radians. Why is that? Because S equals R theta. For unit circle, R is 1, so S equals theta. So we can say sine theta is sine T, cosine theta is cosine T, and the rest of them. So you can change the T to theta, it makes no difference. And all those quadrantal angles that we learned with respect to T, the same thing works with radians. So for example, 0 degrees in radians or degrees, pi over 2 or 90 degrees, pi over 180, 3 pi over 2 or 270. Sine, for example, for the 0, okay, is 0. For cosine is 1, tangent is 0, cosecant is not defined, secant is 1, cotangent is not defined. So exactly the same thing that we did in the previous page works out here for theta. So it's just being repeated. So we are repeating the same concept. All right, we want to find the exact values of the trig functions that are multiples of quadrantal angles. For example, we want to find sine of 3 pi, and we remember x comma y is cosine t or cosine theta, comma sine t or sine theta. So what is 3 pi? If we were to draw this, it means you go a whole revolution and then half a revolution and you stop here. P has coordinates -1 and 0. So x represents cosine, y represents sine, and therefore sine becomes 0. Cosine of -270 degrees. So we draw that and we go in a negative direction, which is clockwise. Positive direction, counterclockwise. and the coordinates are 0, 1. X represents the cosine and y represents the sine. Therefore, the cosine is 0. You should be able to come up with those answers pretty fast, class. All right, we want to find the exact values for pi over 4, which is 45 degrees. And again, we remember that a pair x comma y, for a unit circle, they represent cosine and sine respectively. So let's draw the 45 degrees and see where it ends up. I hope you realize that this, if we were to look at from a linear functions point of view, represents the line y equals x. So 45 degrees. Remember, if this is 45, so is this one. So it's on the line y equals x. And of course, we are in the first quadrant, which means x is positive, y is positive. So let's go with the unit circle that says x squared plus y squared equals 1. And since x and y are the same, let's replace the y with x. And therefore, and again, x and y are positive because we're in the first quadrant. And therefore, we get 2x squared equals 1. Now, this means x squared is 1/2, and x is plus minus the square root of 1/2, or plus minus 1 over square root of 2, and we only take the positive and rationalize it. Okay, so this, if you rationalize, gives you this answer. And because x is equal to y, both of them have the same value. So P has coordinates that are identical. Therefore, cosine of 45 degrees or pi over 4 is square root of 2. Sine of pi over 4 45 degrees is square root of 2 over 2. Tangent, which is the ratio of these two, is 1. The rest are the reciprocals. So this is what we have. We have this one, we have this one, we have this one. Now the reciprocal of tangent is itself. Now the reciprocal of this number, 2 over square root of 2 is square root of 2. In other words, if you look at the reciprocal for these two numbers, you get square root of 2. So for cosecant and secant, both of them, the reciprocal gives us square root of 2. So that's how we get the trigonometric functions of pi over 4 or 45 degrees. All right, now that we have those, let's find the exact values of the following expressions. Sine of 45 times tan of 45. So this number is square root of 2 over 2 times 1. By the way, pi over 4 is a very important common arc. We have to memorize this stuff. So we multiply the 2 and we get square root of 2 over 2 precisely. Secant of pi over 4. By the way, if you don't memorize this, as long as we have those three, the rest of them, we can think of them as the reciprocal. So as long as we know sine or cosine, then we know cosecant or secant. Okay, so the reciprocal of, for example, cosine, the reciprocal of this number is what this is, in case we don't remember that. So it's square root of 2. This is 1. And that's the answer. All right. Again, we are looking at common arcs. We are supposed to know the values. So let's start with the first one. Sine of 45 is square root of 2 over 2. Cosine of 180, I hope you remember it was negative 1. So their product is the answer. Tan of pi over 4 is 1 minus sine of 3 pi over 2 was negative 1. Multiples of pi over 2 when it comes to sine is either 1 or negative 1. And so 1 minus negative 1 results in positive 2. Secant of pi over 4 is square root of 2. You want to square that. Square root of 2, you want to square that, which gives you 2. Cosecant of pi over 2. Let's say I don't remember that. I know it's 1 over sine of pi over 2. And we should know that, of course, sine of pi over 2 is 1, so 1 over that is 1. So square root of 2, square root becomes 2. 2 and 1, they add up to 3. Again, common arcs, we are supposed to know them. All right, these are some definitions we may remember from basic algebra or geometry. So let's quickly go over them. We know that the angle sum property of a triangle says when we add up all the interior angles, they add up to 180 degrees. A triangle is a specific type of polygon having only 3 sides and 3 angles. The angle sum property of a triangle says that the sum of all interior angles of a triangle will always add up to 180 degrees. We have types of triangles with respect to the length of the sides. Scaling triangle is this one. All sides and angles have different measures. Isosceles triangle has 2 equal sides and therefore 2 equal angles. Equilateral, looking like that. All sides and all angles are equal. And because the total is 180 divided by 3, each one must be 60 degrees. Types of triangle with respect to the angles. If one angle is 90 degrees, we call it a right angle triangle. So 1 is 90 degrees. Acute angle triangle, when every angle is less than 90 degrees. Obtuse is the one that one side, one angle must be larger than 90. And by the way, you can never have more than one angle more than 90 degrees because the sum is 180. So these are different terminologies. We wanted to refresh everybody's memory. Now, we want to find the exact values of a trigonometric functions for pi over 6 or 30 degrees and pi over 3 or 60 degrees. And this is one method that will give us the answer. If you look at this right angle such that we know the hypotenuse is 1, so if this is 1 And then we go with 60, 30, right? And this is 1. If one is 30, the other one must be 60 or vice versa because they must add up to 180. Okay. Now let's look at it again. The angle is one of them 30, one of them 60, and make a second congruent triangle. We make an identical one and we put it on the side, on the right side. When we do that, because this is 30 and this is 30, they add up 60 to 60. This is 60, this must be 60, this must be 90. And since they are identical, if this is 1, so is this, and so is this. And so that means 2a is 1 and a must be 1/2. All sides are 1. 2 times a must be 1 and a must be 1/2. Can we find the value of b? Of course, we can use Pythagorean theorem. Remember, a squared plus b squared equals c squared. So a squared plus b squared equals c squared. Now, a is 1/2. When b squared is 1/4. b, we don't have it. B squared and 1 squared is 1. Now, if I subtract the 1/4 from 1, I get 3/4. And if I take a root of that, is square root of 3 over square root of 4. Square root of 4 comes out as 2. So b becomes square root of 3/2, or square root of 3 over 2. Of course, it's plus minus, but b represents a side, cannot be negative. Now, let's do some work. So we got this for 60 and 30. We have this side as 1, this side as 1/2, this side as square root of 3/2, and therefore, if we go with a unit circle, we can say that the x coordinate is 1/2, the y coordinate is square root of 3/2, and of course, we had chosen the hypotenuse to be 1 to fit inside the unit circle, and obviously you can check if you square this number, if you square this number and add them up, you do get 1. And now we are ready to look at the answers. Remember, x represents cosine, y represents sine, and as long as we have those, then we divide y by x becomes tangent, and the rest of them are the reciprocal. So sine is the y coordinate, so it's square root of 3 over 2. Cosine is the x coordinate is 1/2. Tangent is the ratio of this to this, square root of 3 over 2 over 1/2, and that becomes simply square root of 3. So here's the sine. The y coordinate. Here's the cosine, the x coordinate. Here's the tangent, which is the ratio of sine over cosine, and it becomes square root of 3. Again, this is ratio of the two. Now, what about the rest of them? Just the reciprocal. So I want cosecant, the reciprocal of this. I want secant, the reciprocal of this. I want cotangent, the reciprocal of that. 2 over square root of 3. I can multiply by square root of 3 over 3 to rationalize. This one is simply 2. This one, 1 over square root of 3. Again, I can multiply by square root of 3 over 3 over square root of 3. And I get this one again. 60 degrees or pi over 3. It's a common arc. We are supposed to know the trigonometric functions and the values for all of those. We have to know them. Let's do that for 30 degrees, and we can look at it in this format. So this is still 1. This is square root of 3 over 2. This is 1/2. And now, again, the x coordinate represents the cosine, the y coordinate represents the sine, and if we divide y by x, we get to the tangent. So starting with the sine, which is the y coordinate, is 1/2. So sine of 30 degrees or pi over 6 is 1/2. Cosine is square root of 3 over 2. And tangent, we divide this one by this one. The ratio of sine to cosine. I hope you realize 2 drops becomes 1 over square root of 3. Let me show you. So this really becomes 1 over square root of 3. If you rationalize, you get square root of 3 over 3. The rest of them are the reciprocals. Reciprocal of this is 2, that is cosecant. Reciprocal of this 2 over square root of 3 or 2 square root of 3 over 3, that is the secant. And the reciprocal of this is the cotangent, which is square root of 3. So cosecant. Secant. If I multiply by square root of 3, over square root of 3, I can see the answer as 2 square root of 3 over 3. We do the same thing here. If we multiply by that ratio, we get square root of 3. Again, common arcs that we should know when it comes to 30 degrees, 60 degrees, so on and so forth. I can't emphasize this enough. You have to memorize it. And remember the relationship between 30 and 60. By the way, sine of 30 is the same as cosine of 60 and vice versa. And that's a relationship in a triangular shape, okay? Because as you may recall, if you want, this sine is the opposite over the hypotenuse, and cosine is the adjacent over the hypotenuse. And if you go with that, also it will help you see the answer. All right. A rain gutter is to be constructed from a metal sheet of width 12 inches by bending up 1/3 of the sheet on each side through an angle of theta. So we have 12 inches and we bend them a little bit. Prove that the area of the opening is given by this. A of theta is 16 sine theta times cosine theta plus 1. Find the area when theta is 30 degrees, 45, 60. That part is not a big deal. You just plug in. It's a basic concept. But as far as the proof is concerned, we really need to understand, if you look at this shape, this is a trapezoid. And a trapezoid has this equation, 1/2 the height. Here's the height. Times B1 base 1 plus base 2. So the B is the height. This is B sub 2. This is B sub 1. So that's the formula we're going to use, the area of a trapezoid. Now, this angle is theta. So is this one. So is this angle and this angle. Because these two lines are parallel. And so what is the height? This height is equal to B and the ratio of this to the hypotenuse gives you the sine theta, sine of this angle. Let me just write them next. This is theta, so sine theta is the opposite, which is B or H over 4. I hope you remember this is 4. Therefore, H is 4 sine theta. So we have the height. What about B1? B1, 4 inches. What about B2? This one. Now we have this distance, which is identical to this distance, and this is 4 cosine theta. I'll go over that as to why. And this distance is the same as this distance, which is 4. So we have 4 cosine theta, and 4. Why is this 4 cosine theta? If you look at this, cosine theta is the adjacent. Cosine theta is the adjacent over the hypotenuse, adjacent over 4. And the adjacent is the green portion, which makes it 4 cosine theta. And therefore, H is 4 sine theta. B1 is a 4. B2 is this part plus this part plus this part. 4 plus 4 cosine theta plus 4 cosine theta. Practically, we are done. I'm going to erase the extra part so we can easily continue. So let's plug in. So we're going to replace the H with 4 sine theta, and we're going to replace the B1 with 4, and then B2 with all of those. 4 and 1/2, the product is 2. This one, 4 and 4 is 8. This one is 8 cosine theta. And I hope you see that I can take out the 8 here. Which gives us this formula, and we just proved it. That's the main part. The rest is very simple, just plug in. So I don't want to spend too much time on it, but let's quickly go over that. For 30 degrees, so this is the most important part. We proved it. For 30 degrees, replace the theta with 30. And sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. This gives you 8. When you multiply by this, gives you 4 square root of 3, and this gives you 8. And here's the approximation with a bunch of decimals. In the case of 45 degrees, sine of 45 and cosine of 45 are both square root of 2 over 2. So this is 8 square root of 2 times square root of 2 over 2, which, believe it or not, becomes 8. And then 8 This is 8. 8 square root of 2 times 1. Again, this is exact approximation using a calculator with a bunch of decimals, however many decimals they ask. If they don't, you want to go with more decimals. In the case of a 60 degrees, I'm going to change those to 60 degrees. The sine is square root of 3 over 2. And the cosine is 1/2. Again, we get roughly 20.78. Let me just clean something. Okay, just fix something up. This is supposed to be 60. And now, so 8, so this is 4 square root of 3. And yeah, the total is 12 square root of 3, that's right. Because we have 4 square root of 3 and 8 square root of 3, so 12 square root of 3. All right, so this is more like it. Let's continue. So just a quick recap. We are going to prove this by noticing this is a trapezoidal shape. This is the height. We calculate the height to be 4 sine theta. This is B1, it's 4 inches, and this is B2, which is 4 inches, plus this side 4 cosine theta, this side 4 cosine theta. And we do the math. All right, whether you're dealing with t or theta makes no difference. These are common arcs for pi over 6, pi over 4, and pi over 3. We should know them. Exact values of trigonometry functions for integer multiples of those we should also know. All we have to do, pay attention to the quadrant. For example, we remember in the first quadrant, everything is positive, and the reason why, because x and y are positive. But if you look at this quadrant, and I want to just remind you quickly, remember this is y comma, this is x comma y. Let me just rewrite it, x as, okay, so x is positive, that means cosine is positive. Y is positive, that means sine is positive. So when we go to the second quadrant, and this is quadrant 1. As an example, when we go to quadrant 2, we know x is negative. Because x is negative, then cosine is negative, but sine is positive. In the third quadrant, both of them are negative. X is negative, y is negative, so cosine and sine, both of them are negative. However, tangent is the ratio of the two and becomes positive. Quadrant 4, x is positive, y is negative. That means cosine is positive and sine is negative. So we should pay attention to those. Also, if this is pi over 4, this one is 3 pi over 4, 5 pi over 4, 7 pi over 4. All of them have something later on we refer to as a reference arc, which is pi over 4. So all of them have the same value as the pi over 4. With respect to the quadrant, you adjust for the sign. For example, if you are interested in cosine of 3 pi over 4, you say, well, I know that cosine of pi over 4 is square root of 2 over 2, but in this quadrant, cosine is negative. So that's how you arrive at the answer. Now, the same thing happens with pi over 6, okay? Then 5 pi over 6, 7 pi over 6, and 11 pi over 6. The same concept of a quadrant works out here, okay? The x represents the cosine. So cosine of pi over 6 is positive square root of 3 over 2. So is sine, which is 1/2. When you go to the second quadrant, now cosine becomes negative, but it has the same value. In the case of pi over 3 or 60 degrees, again, the same thing. Pay attention to the quadrants. I hope everybody is following that. So with that being the case, let's look at cosine of 150 degrees, which is the same as 5 pi over 6, by the way. You can go back and forth from the radians to degrees and vice versa. So this is the same as 5 pi over 6. We are looking at a cosine, which is the x coordinate, and makes it negative square root of 3 over 2. We should really know all of those. As long as we know what's happening in the first quadrant, then we can figure out everything in the other quadrants. Now, minus 30 degrees or minus pi over 6. So when you remember that sine of 30 degrees is 1/2, okay, sine for negative pi over 6, okay, and sine is represented by the y coordinate, puts you in the fourth quadrant, and therefore in the second quadrant, and it makes it negative. Sine of negative 30 degrees in the fourth quadrant, my apologies, in the fourth quadrant, and sine is the y coordinate, and it becomes negative 1/2. So we are looking at negative 1/2 here. Tan of 4 pi over 3. Tan of 4 pi over 3, we are here. And remember, tangent is the ratio of sine to cosine. Both of them are negative. Negative over negative makes it positive. Sine of 7 pi over 6 puts us in the third quadrant. In the third quadrant, both sine and cosine are negative. So the same as pi over 6, which is 1/2, but negative. So again, I highly recommend you get comfortable with this concept of reference arc, which we will look at with more details. All right, what if we want to use a calculator? We want to be careful that the calculator is in the proper mode and we know all of them. So if I want cosine of 48 degrees, I just use a calculator. Cosine of 48 degrees. Cosine 48, and it has to be in degree mode. I want cosecant. When I want cosecant, I know that cosecant is 1 over sine. So you can find sine of 21 degrees and then reciprocal of that, or 1 over sine of 21. And you get to the answer. Tangent of pi over 12. what you really want to be careful is that you want to make sure you change the mode to radians. Calculators, graphing calculators will give you a chance. So you go to the mode, and over here, you want to make sure that radian is highlighted. If it's highlighted, then tan of pi over 12 gives you the answer, 0.26794. And then you continue with however many decimals that they ask you. So be very careful when it comes to that. The next topic that I want to look at, what if we have a general circle where the radius is no longer 1? So if you look at the unit circle, x squared plus y squared equals 1, that's fine and dandy. But what if we have x squared plus y squared equals r squared? In this case, what happens is that, remember the sign was y, but remember r was 1 in a unit circle, but it's no longer 1. So we have to divide y by r. Cosine theta, we have to divide x by r. Tan theta doesn't change. Cotangent theta doesn't change. Now, if you look at the reciprocal concept, cosecant and secant do not change either. But from the point of view of y over r being sine, cosecant becomes r over y, so on and so forth. So x squared plus y squared is no longer 1, it's r squared. P has coordinates x and y. If we call them a, b, then sine is y over r or b over r. Depending upon the text, they may call it a or b. Cosine is x over r or a over r. Tangent doesn't change, y over x or b over a. Cotangent is the reciprocal of that, a over b. Cosecant is r over y or r over b, and secant is r over x or r over a. So as usual, as long as you have sine and cosine, pretty much you're ready to write the rest of them. It's really not that big of a deal. So let's quickly look at this example where we have the two pairs. We want to find the exact values. And the very first thing we want to calculate is the value of r, which means we're going to square this, we're going to square this. And we need to know the location as well. So let's do that. Here's the location, 4 to the right, 3 down, which puts us in the fourth quadrant. And when we square 4 and -3, they add up to 25. It comes out as 5 because it's 16 and 9. So 4 squared is 16 minus 3 quantity squared is 9. They add up to 25. The square root is 5. So we have x and y, or a or b. We also have the value of r. So you want to be very careful with that. Now, so what is sine theta is, remember it was the y coordinate. So the y coordinate, but this time divided by r, so b over r, so -3 over 5. What is cosine theta is a or x divided by 5. And what is tangent theta, it's just the ratio of those two, -3 over 5 over 4 over 5, which makes it -3/4. So b over r, a over r, b over a. So b over r, as I mentioned, -3 over 5, a over r, 4 over 5, and the ratio of the two is really the ratio of these two, -3/4, because this one I can write as such. Now, what about the rest of it? For here, I'm going to go with cosecant, and it becomes -5/3. For here, I'm going to go for secant, and it becomes 5 over 4. For over here, I'm going to go with cotangent, and it becomes -4/3. All of them are the reciprocals. So when we have a general case x squared plus y squared equals r squared, we just want to be careful with sine and cosine. The rest we can use sine and cosine to get to the answer. Here's the last question. We want to find the exact values for those expressions, starting with cosine of 135. And by the way, 135 degrees, it's a multiple of pi over 4 or 45 degrees. And 135 degrees, that puts us in the second quadrant, and it's right here. Those are the coordinates class. And cosine is the x coordinate, so it's minus square root of 2 over 2. In other words, cosine of pi over 4 or 45 degrees is square root of 2 over 2. In the second quadrant, cosine is negative. The next one, 3 pi over 4, believe it or not, it's the same location. 3 pi over 4 is the same location. And you really should know the tangent is -1, or just the ratio of the two when you divide the sine by cosine. 225 degrees. Remember, this is 180. This is 270, so it's in the third quadrant. So believe it or not, it's right here. Again, multiples of pi over 4 or 45 degrees. So it's right this pair. And since we want sine of 225, it doesn't matter. Both of them are negative square root of 2 over 2. But sine is the y coordinate. Again, you can think of pi over 4 or 45 degrees, which is square root of 2 over 2 in the third quadrant. Okay, sine is negative. Sine is positive in the first and the second quadrant. Cosine of -5 pi over 4. So -5 pi over 4, when you start from here and you go -5 pi over 4, puts you in the second quadrant, so right here. Or you can think of cosine of pi over 4, which is square root of 2 over 2 in the second quadrant. Cosine is negative, so it gives you minus square root of 2 over 2. 9 pi over 4, I hope you realize this is 8 pi over 4 plus pi over 4. In other words, this is equal to pi over 4. So it's a complete revolution. And then we add pi over 4. So this is the same as pi over 4. You want sine of it, sine of pi over 4 is square root of 2 over 2. As I mentioned, we can use reference angle or arc. We use theta prime or theta hat. This is theta hat. In quadrant 1, we use theta hat. In quadrant 2, we use pi minus theta, whatever the value is. In the third quadrant, we write theta minus pi as theta hat. And in the fourth one, 2 pi minus theta. The reference angle, and we discuss it further, is the closest angle that the terminal side makes with the x-axis, positive or negative, doesn't matter. The closest angle that it makes with the x-axis.